Okay, guys, today we're going to start looking at the graphs of polynomials and just kind of analyzing what's going on with them. This should look very familiar to what we did in Unit 1. But let's just do a quick refresh, okay? When we're talking about the minimum or the maximum, we're talking about a point. So an x value and a y value, okay? That's for both the min and the maximum. So it's just going to be a single point. And for minimum, that's going to be at the bottom of the curve, right? It's going to be down here at the bottom. Down in the valley is the way some people describe it. But it's just at the bottom of the curve. It's the lowest point of the curve. And the maximum is going to be the highest point on the curve. Okay? It's going to be up top, the mountaintop, okay? So you're looking for the top of the curve and the bottom of the curve. Bottom for minimum, top for maximum. Okay, domain and range. Remember that domain, we're looking at the x values. So we're going to go from left to right. And our domain, if it starts at negative infinity, okay, or can end in infinity if it's not a hard point. And those are always going to be with parentheses. We're going to use brackets when we have numbers, right? So it may start at a number. If it includes that number, we use a bracket. If it doesn't, we use parentheses, okay? So we can mix brackets and parentheses. We may also start at negative infinity and then stop at a number. Okay, so left to right. Negative infinity is always on the left. Infinity is always on the right. Positive infinity, always on the right side. Okay, range is our y values, right? And we list the y values from the low point to the highest point, or from the bottom to the top. Low to high. And that's going to include oftentimes our minimum or maximum. Okay, it can be our range, minimum or max, can oftentimes be included. So those low points or those high points, if they're the absolute mins or the absolute max. So you won't just, as we get into some of these examples, you'll see that sometimes we have a relative min or relative max that is not the bottom or the top if it exceeds further at other places, okay? The examples over here, all these, same for range, right? The low point's going to be the negative infinity with a parentheses. Sometimes we might have a higher low point with a number with the bracket, okay? So the lowest is always negative infinity, highest is always infinity, okay, as far as when we're using those infinite signs. Okay, increasing and decreasing, that's always going to be parentheses, okay, parentheses only. I'm going to make a little note up top, just a big bold note so we don't forget, parentheses only, no brackets here, okay? Where they stop increasing and decreasing, it's not increasing or decreasing, so it's parentheses. Okay, when we're increasing and decreasing also, we only use x values. Okay, so increasing is x values only. Okay, so the increasing parts are where the graph is going up from left to right. Okay, where it's rising from left to right. Okay, so we're using those x values left to right. And then they may stop increasing and decreasing at min or max. So mins and maxes are going to be stopping points as well. Okay, so you're going to have your negative infinity, your positive infinity, you're going to have your min and max x values. Okay, the decreasing side, same thing. We're doing x values again, always x values, increasing and decreasing. But for the decreasing part, that's where the graph is going down, right? That's when the slope's going down, so going downward. Instead of rising from left to right, it's headed downwards. So same thing, it's going to stop at mins and max, and we're going left to right. Okay, let's dive into some of these examples. If we look at example 1, we do see a relative min, right? We have this relative min here at 0, -4. That's a low point there. So I'm going to go ahead and write 0, -4. It's a point. We also have the relative max here at -2, 0. Our domain, how far left, how far right. The left side, it's still heading a little bit left as it goes off the graph, and same with the right side, it's still going a little bit to the right. So our domain is going to be -infinity to infinity. Very common answer for functions. Our range, lowest, as you can see, it's going off here, off the graph there, going off the graph there. So it never stops going down, never stops going up. We do not use those min and max here. Those are relative min and max, not the absolute min and max. So our range is going to be -infinity to infinity. Okay, then when we're looking at increasing, I see two different intervals really where we're increasing. I'll go back to red on this. The graph is going up from left to right here, and then it's going up right here. Okay, so we have two different intervals of increasing. And if we look in between here, it's going downward. Okay, so we only want those x values. So we're going to use that those domain and range x values. We're also going to use the x values of the min and the max. Okay, so let's start out here. The increasing, the first interval is increasing. So that started at -infinity and then stopped increasing at the x value of my max, which was -2. Then it started decreasing. It started decreasing at -2 and stopped decreasing at infinity. So -2 to infinity. I should have made a little more room here. So we also have an increasing value. There's my union, because we're going to include the other increasing value from 0 to infinity. We start increasing at the minimum there, 0, and keep going to infinity. So I'll just squeeze that in here. 0 to infinity. Okay, that's it. Done with that example. Moving on to the next one. Minimum here. We have another minimum over here. Okay, so two minimum values, -1, 2, not -2, -1, 2. It's a +2. And then we have another one at 1, 2. Okay. Then we have the max. The max is right up here at 0.5, nicely labeled for us. Appreciate that. Domain, -infinity to infinity. Never stops going left, never stops going right. Okay. The range. Well, the lowest this graph ever goes, the lowest y value, it's right here, right? 2. So that's where our graph's low point is. So I'm going to put that, since it's a number, it goes in the bracket because it is included. And then it never stops going up, it goes off to infinity. Okay. Increasing, decreasing. Let's see. As the graph starts, it's decreasing. Then it starts increasing. Then it decreases again. And then it increases again. So we have 2 decreasing, 2 increasing. Let's go ahead and write the increasing first, the x values. We start at -1. We stop at 0 for this first increasing interval, -1 to 0. And then we start increasing again at 1, and we never stop increasing, so it goes on to infinity, 1 to infinity. Decreasing, we start for this decreasing, we start at -infinity, and we stop decreasing at -1. Then our other interval starts decreasing at 0, stops decreasing at 1. So notice I only used the x values. I didn't use y values anywhere in there, okay? All right, last example, minimums and maximums. We have 3 minimums here, 3 low points, okay? -5, -5 is the first one, 0, 0 is the second one, and then 5, -5. Maximum, 2 maximums. 1 and 2. -2, 2 and 2, 2. Okay, domain, -infinity to infinity. Range, lowest point, y value would be -5. -5 here, -5. That's my lowest. Never stops going up. We got these arrows shooting off to infinity here. So -5 to infinity for the range. Increasing, we have an increasing here, and increasing over here. Okay, so 3 increasing intervals. I'm gonna go ahead and list those out. We're doing x values again, so we start increasing at -5, this -5, the x value. Stop increasing at -2. Okay, then we increase from 0 to 2. And then we have one last increasing at 5 to infinity. Okay, then we have our decreasing, -infinity to -5. Then we decrease from -2 to 0. And then we decrease from 2 to 5. Okay, that's analyzing polynomial graphs. If you have any questions, please ask Gonzalez Campbell or myself. And go ahead and complete the practice work. We're available to help. Thank you.